Hey gang, we're going to look at investigating functions today. And so I've got two functions over here on the left. You'll notice I'm on Desmos. So you could use your graphing calculator, or I highly recommend using Desmos to graph as well. It's very easy, very intuitive. So we'll start down here with this f of x equation. So f of x equals the square root of x plus 5 minus 3. And I already have it graphed over here just by typing in the equation. So that's kind of, step, well, there are a few things that you need when you're investigating a function. You should write the equation, okay, which we've got that by typing it in. We should graph, and just by typing it in, we get the graph of it. You should create a table of values to see what that table looks like. Now on Desmos, to create a table, you're going to have to make sure that you've got that equation, that you clicked on that equation, and you go up to the gear, and you click the gear, and then you can see this little button here that says convert to table. So if I click that, now it's converted that equation to a table. And it still has the equation up there, but now we can see some different values for our table. We could always add more values. So I can go down here, and just by hitting enter, it puts in 3 and 4. Maybe I want to add one that comes up before -2. So all I have to do is type in -3 here for x, and it tells me what f of x is. If I type in -6, you'll see that it says undefined. Well, if we look over here at our graph, it doesn't go to -6. If we think about our equation, if we plug -6 in, -6 plus 5 is -1, we'd be square rooting the -1, which is not a real answer. So that's why it's at -6 here in our table, it's undefined. But so we've got an equation, we've got a graph, we've got a table. Now what we want to do is we want to identify key points. Okay. And when we talk about key points, we're talking about a few individual points here. We're talking about any x-intercepts, any y-intercepts, and perhaps a locator point, if there's a locator point. So for our x-intercepts, if we look at the graph here, you can probably see where that x-intercept is. But also a nice thing with Desmos is that if you actually click on the graph, it'll tell you the point. So the point is 4, 0. So remember, the x-intercept is where the graph crosses the x-axis. And for this graph, that's at 4, 0. Be careful, some graphs have more than one x-intercept. Make sure you label all of them. For our y-intercept, that's where it crosses the y-axis. That we can usually see from our table here. We could also get it from our graph. We could plug 0 into our equation for x as well and solve for y. But if we just look at our table, we can see that when x is 0, y is approximately -0.76. Okay, so 0, -0.76. And then a locator point. So for a square root function, our locator point is where the square root function begins. So this square root function begins right here at -5, -3. If you remember from graph transformations, h and k, -5, -3. So that's our locator point. We also want to identify that point, -5, -3. Okay. So now we've identified our key points. The next thing we'd like to do is we'd like to find the domain and the range. So remember, the domain is your x values. Okay. So we think about starting on the left here, and the first x value that's on our graph is -5. Okay. So we're going from -5, and we touch -5, so -5 is less than or equal to x. And then this graph is going to keep going forever to the right, because we could plug in any size x value that's really big in the positive direction, and this equation would still work. So you could leave it like this. If you wanted to, you could write less than infinity. Or if you were going to use interval notation, remember you'd use a square bracket for equal to, so -5, we can be equal to that. And then we're going up to infinity, and we can't equal infinity, so open bracket or parentheses there. For our range, that's our y values. So we look at our lowest point. The lowest point is -3. So we're going from -3 less than or equal to y. And then our highest point, well, this is climbing slowly, but it is going up and it's going to continue to go up. So it's going to infinity. Or in interval notation, -3 to infinity, like that. Okay. So domain and range also is important, needs to be included anytime you're investigating a function. And then the last thing is asymptotes. Okay. So asymptotes, remember, basically is a line that our graph is approaching. A square root function does not have any asymptotes, so you should just say none. Okay? But it is important to identify whether there are any asymptotes or not. Okay? So this was investigating a function for a square root function. Let's look at another example. Okay? So we'll look at this example up above. G of x equals 3 over x minus 4. So step 1 was write the equation. I've got the equation. Step 3 I had was the table. So I've already done the table for you. Step 2 was to graph it. So I'm just going to get rid of this graph here and put this one up. So there's the graph for this one. I'll just make that a little bit easier to see too. So we've got the graph. So equation, table, graph. Now let's identify some key points. So x-intercepts, y-intercepts, and locator point. And looking at this graph, we don't see any x-intercepts. Perhaps if we zoomed out, maybe we'd be able to find some x-intercepts. But if we just think about what an x-intercept is, an x-intercept means that the height of your graph, your y value, is at 0. So if we think about our equation over here, if we try 0 for a y value, is there anything that we could divide 3 by to get 0? And the answer is no. We could try to go as big as we want. Okay, the bigger we divide it by, the bigger the number in our denominator, the smaller this fraction would get, the closer it would get to 0, but it could never reach 0 because it would always be 3 divided by and some really big number, which would just be a really small number. So this graph does not have any x-intercepts. Y-intercept, we could plug 0 in for x here. We could look at our table, or we could click on the graph. Looking at the table is probably the easiest. We can see that our y-intercept is at 0 and -0.75. And then the locator point. I'm going to come back to that in just a second once we get down to the asymptotes. So let's look at the domain and the range. So these are going to be a little bit trickier for a hyperbola. That's what we have here is a hyperbola. Our domain, well, this graph is going to go forever to the left, and it is going to go forever to the right in the positive direction. So we might think that our domain is all real numbers, but we can see that there's a gap in here. And if we think about x values, there's one number that you can't divide by. You can't divide by 0. So if x is 4, then we'd be dividing by 0 because we'd have 4 minus 4 in our denominator, which means 4 doesn't work. Any other x value will work, but 4 does not work. So you could say your domain is all real numbers except 4, or another way to write that would just be x not equal to 4. Okay. Our range is similar. We can see from the graph that this is going to keep going down forever. It's going to keep going up forever. But again, we have this gap in between. And remember, that gap told us we didn't have any x-intercepts. That gap was when y was 0. This fraction could never equal 0. which means our y value can never equal 0. So y not equal to 0. All right, now the asymptotes. For a hyperbola, we've got a couple of asymptotes here. We have a horizontal asymptote. Okay, so a horizontal asymptote. Remember, horizontal is a flat line going straight across. And we can see that that line is right here at y equals 0. Okay. Remember, our range, we couldn't be 0. Y couldn't equal 0. Well, that's because we had this asymptote here at y equals 0. From both sides, as we go out towards negative infinity or positive infinity, the graph is getting closer and closer to a height of 0. That's our horizontal asymptote. Our vertical asymptote, okay, that's a vertical line. And again, we can see where that is, where this gap is. That was at 4, x equals 4, because our graph never touched x equals 4. That wasn't part of our domain. Okay, so sometimes you might draw a horizontal line in there. Sorry, that's kind of wiggly. For the asymptote, vertical line, and now a horizontal line for this one. Okay. And that brings me to the locator point. For a hyperbola, the locator point is where those two asymptotes intersect. So that point here is at 4, 0. So that would be our locator point for a hyperbola. So just to recap, when you're investigating functions, step 1, you want to write the equation. I'll go back to the previous slide here. Step 2, graph it. Step 3, make a table. And you can switch steps 2 and 3, but equation, graph, table. Then label the key points, x-intercepts, y-intercepts, locator points. Find the domain and the range. And if there are any asymptotes, you want to give the equations for the asymptotes. And that's everything that goes into investigating a function.